Professor Dr. Insinyur Dr. Wan Ramli Wan Daud is a professor at National University of Malaysia and founding president of Malaysian Association of Hydrogen Energy. He got his PhD degree from University of Cambridge, United Kingdom in chemical engineering in 1984. He also a founding director in Fuel Cell Institute UKM. So, Professor Dato Insinyur Dr. Wan Ramli Wan Daud, time and screen are yours.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. First of all, I would like to thank NEDO for inviting me to give some thoughts on the hydrogen trend in Malaysia. I would like to share the PowerPoint. Yes, I would like to thank NEDO for giving me the opportunity to speak on the hydrogen energy trends in Malaysia. But for the benefit of the audience who may not be familiar with the issues of why we need hydrogen, I would like to have a brief discussion on the two challenges of the world. One is energy security, and the other is climate change. The world energy supply is nearly 600 gigajoule, and consumption is about 400 gigajoule, and about 80 to 90% of the total energy is from fossil fuel, and fossil fuel reserve depleting, and production is peaking. Yeah? That means it has reached its maximum production rate and will be declining in the coming years. So there is the issue of getting the enough energy to fuel the economy. The other problem in the world is, of course, climate change caused by global warming and carbon emission. In 2015, I think the world leaders have met in Paris to sign an agreement called the COP21 in Paris Agreement, in which they all are committed to strengthen global response to keep temperature rise below 2 degrees C. And you can see the effect if you continue not to act or business as usual. You can see the top red line will go on increasing, and that would cause a catastrophic climate to the world. Yeah. So if you keep the temperature below 2 degrees C, and you can see that the green line, that should be the ideal pathway in which the world could try to reduce carbon emission and to prevent climate disaster in the future. So most countries diversify their fuel sources with low zero emission energy, renewable, such as biomass, biofuel, solar energy, and wind energy, and of course green hydrogen energy and nuclear energy. But nuclear has some issues, as everyone has seen in the Fukushima disaster and so on. And many of the countries also developed their green technology, including low or zero emission clean energy technology. And you can see that in the future, there will be a lot more renewable energy being used in electrical generation, yeah, in the future. And there will be no more oil being used for electricity generation, and the single energy sector that grows would be the renewable energy. As you can see at the top, it's growing at quite a fast rate. So that's what the world wants to do. And if you look at the renewable energy of the world, and it's increasing, a lot of hydro, and then wind and solar is also increasing, and bioenergy a little bit more at the top. So what is Malaysia going to do? Well, at the COP 21 Paris Agreement, Malaysia is committed to cut carbon emission intensity by 40% of 2005 level by 2035. And in meeting the target, Malaysia will continue energy efficiency effort and conservation as well, and also to increase the renewable energy in the energy mix to about 20% by 2030, and to encourage electric vehicle in the transportation sector. But the problem with electric vehicle, the electricity produced is still emitting carbon dioxide. So it's not it's a partial solution. Yeah, if the electricity is still mainly produced from fossil fuel, so you need to actually increase RE target as well as the deployment of electric vehicle. So hydrogen could be used as the sixth energy or sixth fuel, as it's called in Malaysia, in our energy mix. So at the moment, our energy mix, there are 5 fuel. Yeah, and the 5th fuel is renewable energy. And so if we were to integrate into the national energy policy, it has to be as the 6th energy in the total energy mix. In the transportation sector, maybe there is some opportunity to introduce green hydrogen fuel cell vehicle together with the electric vehicle that are already being planned. So we'll look at the evolution of Malaysian energy policy. In 1974, when we found that we had a lot of oil, so we need to have an act to regulate the oil industry. Before this act, both ESSO, or now Exxon, and Shell had found oil in Malaysia, and they had there is no proper regulation, national regulation to exploit the oil for the nation. So the Petroleum Development Act gave the government or Petronas to actually acquire all the oil wells, yeah, and then to sign a profit sharing agreement with all the oil companies. And in 1975, we formulate the National Petroleum Policy. And when there was in 1979, when there was the Iran-Iraq war, and this issue of oil security, we developed the National Energy Policy and the National Depletion Policy in 1980, yeah, so that we could conserve our oil. And because of the problem with the war, we then develop, we diversify our fuel for electricity generation, and we have this 4 fuel diversification policy in 1981. And the 4 fuel are petroleum, natural gas, coal, and hydro. It's only in 2001 that the government of Malaysia recognized the need to introduce renewable energy in the energy mix. And so in 2001, we have the renewable energy as one of the 5th fuel mix. Yeah, hydro is a renewable energy, but in the parlance of the energy ministry, renewable energy is other than hydro, but it's also include mini hydro, micro hydro as well. And we kickstart the renewable energy policy by having the small renewable energy power, and the many mainly solar energy and biomass. And then in 2006, the Ministry of Energy commissioned the Energy Center Malaysia, which is now called the Green Tech Corporation. It has been changed recently to Malaysian Green Tech Center, Green Tech and Climate Change Center, sorry. A roadmap for solar, hydrogen, and fuel cell, in 2006. Now, this roadmap shows the pathway in which Malaysia should take to develop the solar energy, hydrogen energy, and fuel cell in the future. And the program in the roadmap was employed in the 9th Malaysia Plan, but in subsequent Malaysia Plan, it was neglected by successive Malaysian government because of other priorities. In 2006 also, Malaysia had developed the national biofuel policy, that is to introduce biofuel at the pump station, B5, B10, and B20. Also by 2010, there is another roadmap that consolidates the solar, wind, and biomass into one roadmap, and it's called the Renewable Energy Roadmap. Unfortunately, hydrogen was not part of this renewable energy roadmap, and somehow it was neglected. And as a result of the roadmap, the Malaysian Parliament approved the Renewable Energy Act in 2011, as well as the SEDA Act. SEDA is the vehicle to implement the feed-in tariff for renewable energy. SEDA is the Sustainable Energy Development Authority. And in 2017, the Academy of Science Malaysia had revised the 2006 roadmap since it was not being implemented beyond the 9th Malaysia Plan. So the Academy had revised the roadmap and had proposed a new one, which we are now proposing to the government of Malaysia. The FIT for renewable energy deployed by SEDA ended in 2016, and the Energy Commission had taken over and had introduced net energy metering, and in 2017 followed by large-scale solar, of 100 megawatt and above. So it has already been deployed, and the target is 20% by 2035. And in the new roadmap by the Academy, we want to suggest that hydrogen should be the sixth fuel, which should complement the renewable energy as well. And Malaysia government is also deploying policies for electric vehicle for transportation. But as I said, the electrical power still emit carbon. So it is not solving the problem, but only partial part of the problem. So we're going to ask for the transition to green hydrogen fuel cell vehicle as well in the future. So in the future scenario, it's not replacing fossil fuel with renewable energy, but there will be a portfolio of energy I mean, fossil energy would still be dominant for a lot more years, but it should be replaced slowly by renewable energy and alternative energy such as hydrogen. And of course, as you can see, each form of energy has its own advantages as well as disadvantages. And that's why no one source of energy would replace all the rest. So there'll still be a portfolio of this. Now, the idea is to replace the economy based on fossil fuel. So the red lines are all fossil fuel, and the and gas, yeah, the light blue line, and very few renewable energy. You can see only one windmill and solar, right? So is to transform to an economy where it is based on electricity from renewable energy and fuel from hydrogen. So you can see here the solid blue line, that those are electricity from renewable energy. There are a lot more renewable energy to transform this fossil fuel-based economy into one that is based on electricity from renewable resources, wind and solar and so on, and on hydrogen fuel. As you can see here on the right, the solid blue line, these are the electricity, and the light blue flame, and that's the hydrogen. Yeah, so it is a transition or transformation from a fossil fuel-based economy to one on renewable electricity and renewable or green hydrogen. So this is the hydrogen economy. Of course, for the audience who are not familiar with hydrogen economy, it's a type of circular economy where hydrogen is produced from renewable resources, from splitting of water using electricity from solar power or from hydro or from wind energy to produce hydrogen. And hydrogen is an energy carrier, and it could be applied or used in various industrial sectors, in power generation industry, as well as in transportation. And the net product of the application of hydrogen is water, which could be recycled back through the splitting of the water into hydrogen by renewable energy sources. So it's a kind of circular economy, and this is a very good thing for the world. In Malaysia, most of the R&D on fuel cell and hydrogen energy is done at the Fuel Cell Institute in University Kebangsaan Malaysia, Cell Fuel, established 16 years ago, and I have a 20-year research history. This is very important because we need, Malaysia need to have the R&D expertise in hydrogen and fuel cell in-house so that it could accelerate the implementation of hydrogen. And this is the institute at UKM Malaysia. The first 3 directors, I was the founding director. At the same time, we also need an advocacy association, hydrogen advocacy association that would campaign to with both government and the public for the adoption of hydrogen energy in Malaysia. And I'm also the founding president of the Malaysian Association of Hydrogen Energy. And we had also relation with the Indonesian IJFE as well as the International Association of Hydrogen Energy. And we have international networking all over the world for R&D in fuel cell and hydrogen energy, including Japan, including Japan. And the main research group in the institute, as well as in Malaysia, is first, of course, the fuel cell electrochemical processes that included the electrodes, the membranes, and the membrane electrode assemblies of PEM, as well as other fuel cell. There's also a group of process system engineering and bipolar plate material. This group developed prototypes for fuel cell and fuel cell application, like the fuel cell buggy and motorcycle. And there is also a lot of research activity on solid oxide fuel cell, mainly in the development of low temperature solid oxide fuel cell material. And there's also a big group on direct micro fuel cell, mainly for application as a charger for mobile phones and laptops and so on. Also, we have a group on biohydrogen and microbial fuel cell. You can actually produce electricity from wastewater directly instead of converting to hydrogen and then using the hydrogen to produce electricity. You can actually produce electricity from microbial fuel cell directly. And a foot in the future is the solar hydrogen group, where they develop a photoelectrochemical cell. This is the holy grail of hydrogen energy, where you could produce hydrogen in one step using solar energy in a single equipment called the photoelectrochemical cell. And lastly, of course, we also developed technology to convert primary fuel into hydrogen energy. And these are some of the products from R&D in Malaysia, prototype fuel cell power generators for portable power, fuel cell powered motorcycle. And these are all in the early 21st century, 2002, 2005. And then this is the education kit that we developed, and we are in the process of commercializing it and using it in STEM activities. Mobile phone charger, this is an early prototype and a smaller and sleeker version would be produced by a company. We also developed several fuel cell powered vehicle. In this picture, you can see Daud Mahathir riding with me in the fuel cell. So we developed also a fuel cell buggy for big companies, large companies that have R&D collaboration with us in hydrogen energy. And we also have developed a PEM electrolyzer, and we are also now developing an AEM electrolyzer for another client. So there'll be the supply chain at the moment is only blue hydrogen from fossil fuel without CCS, carbon capture and storage, or carbon capture and utilization. But at the moment, countries are considering gray hydrogen, where carbon dioxide is being captured, stored, and also utilized. And of course, the development of the supply chains is very important to solve the problem of supplying the hydrogen to the application. And several large demo projects in Europe and Japan, and also in the US, Korea, and China had done some demonstration project on the supply chain in order to solve some of the problem in supplying hydrogen to the. In the future, hydrogen is to be produced from renewable energy resources and from biomass, wave, solar, and wind energy. And there's another new one called the ocean thermal energy conversion. If you have a very deep trench, Malaysia have one, a deep ocean trench, you could develop or you could use ocean thermal energy to convert into electricity and then to produce hydrogen by electrolysis. And at the bottom is the photoelectrochemical cell, which would produce the hydrogen in one single cell. And of course, we have zero emission. Now, the other challenge is the cost of production. Yeah, if you look in 2099 from ARENA, you can see that some of the costs for one kilogram of hydrogen, and here at the end here you can see that the cost is around $2, nearly $2, yeah, with the carbon capture and storage, yeah, $3 per kilogram, and in biomass as well. So this two is now currently the cheapest, but in the future the cost by solar energy is going down, yeah, and you can see this. The cost of electricity from RE is going down. So I think all over the world, people are looking at solar, and in places where you have wind energy and biomass energy is now falling to fossil fuel price range. So hydrogen production from biomass and water electrolysis by cheap renewable energy are economic now because of low cost of biomass and solar PV, as well as from wind energy. So in Malaysia, we have a lot of renewable energy resources, and you can see one place, which is Sarawak. We have a pilot project, and this has been said by the previous speaker, where you use hydropower to produce hydrogen and use it in a public transportation project. So there are plenty of renewable resources in Malaysia that we could use for green energy. And so this is the original roadmap, where actually we were supposed to have the demo project in 2009 and 2010, but this is at the end of the 9th Malaysia plan, but the government of Malaysia didn't continue the roadmap. The same way for the fuel cell roadmap as well. You can see that the demo project was supposed to be in 2010, but it wasn't implemented. So in 2017, the Academy of Science Malaysia updated that roadmap. We are now working on this and trying to convince the government to adopt this roadmap. And you can see that the pilot demo project would be in 2025 onward, yeah, because we have to start from back to square one, where we work on codes and standard, public awareness, policies to support hydrogen infrastructure and so on. And we are now in discussion with the National Economic Planning Unit. This afternoon, we will be presenting this to them, and we will try to get them to adopt this roadmap. And of course, hydrogen supply to Japan, I think, is being planned by Australia, Norway, yeah, and also Brunei. I think has been the pilot project is already going on. And in Malaysia, there's a possibility of supplying hydrogen to Japan by two methods. But I think the one that people are looking at is by using either ammonia or MCH, yeah, like the one that has been discussed by the previous speaker. Petronas vision, yeah, that was shared with us. In the short term, hydrogen is used as a decarbonization solution. Yeah, so management of carbon dioxide emission across Petronas value chain via carbon dioxide conversion by hydrogen. So, and development of indigenous green hydrogen production technology with UKM Fuel Cell Institute. But in the medium and long term, hydrogen enable potential business growth. One of this is green hydrogen as clean fuel for power generation and transportation using UKM technology, among others, and could be sold to Japan in the near future. The national utility company, the largest utility company in the country, also have a hydrogen roadmap, but they are also looking at decarbonization instead of using it as a fuel. But in the long term, as you can see way forward, hydrogen application for energy storage and hydrogen for portable power generation. So these are the two large companies in Malaysia who are doing a lot on hydrogen. And then, of course, the Sarawak project. I had the opportunity of riding the car, the Hyundai car, the Sarawak SEDC let me drive it at the launch. Yeah, so this is a Hyundai Nexa car. So I think Sarawak is a place where hydrogen economy will thrive because the political leadership have bought the idea. In fact, the chief minister is the one who drove the adoption of hydrogen in the state. So, and these are their plan. I think that has been introduced by the previous speaker. And so thank you very much.
NEDO.